Hi, good morning. Thank you for joining me here. It's May 1st. May 1st, and another day to go with this radio. But before I do that, though, I want to share something with you that I find a little bit surprising. Anyway, how many people don't seem to really understand this? And I'm going to compare the Canadian justice system to the American justice system and draw a difference between them that seems to be overlooked all the time. So here in Canada, if I were to commit a serious crime, the police would get on to it, potentially, and then perhaps in discussions or on their own, they would decide whether I should be charged with a crime and drawn into the justice system to be tried. Just the police, or sometimes the police in conjunction with the prosecutors. Here in Canada we call them the Crown or the Crown prosecutor. They might have a discussion about, is this really a case that can be brought to court or not, and then the two of them would decide if I'm going to be charged. Just the system decides if I'm going to be charged. In the American system, there's something standing in the middle. There's a jury. There's a jury of ordinary citizens, and they listen to what the Crown or the prosecutor has to say, and they decide if charges are going to be laid, and with the help of the prosecutor, and they'll decide what charges are going to be laid. It's a jury. It's a jury of American citizens who decide if Americans are going to be charged with serious crimes. That's an incredible safety system that Americans have that we don't have here in Canada. If our government and police forces went haywire, there'd be nothing to protect us from them. They have it all in their hands. Whereas in the American system, as I mentioned, there's something standing in between. A pile of ordinary Americans, a jury of ordinary Americans. I've been hearing this thing, grand jury, all my life, because I live in Canada. We're right next to the United States. And really it was later in my life when I began to realize that, what this grand jury is, because it didn't fit, because there's no such thing here in Canada. And I believe, correct me if I'm wrong, there's no such thing in most any other country. I don't know. I just imagine most countries are like Canada. The police and I don't want to use the word government, because it's not really the government. It's really an agency of the government, the police and the Crown, that are going to decide if you get charged. So anyway, I just wanted to draw attention to that. So every time you hear a American person say, and this is coming right from their media people sometimes, that somehow the President of the United States is behind charges that are being laid, just remember, there's a jury sitting there preventing that from ever happening in the United States. It can't happen. No, there we go. Okay, now enough of that. Let's go on with this. And would I like to have a grand jury here? As far as I know, our system works fine the way it is. So I don't think that stuff is necessary. But okay. So what happened here? So tried making this radio work. Still not working. Very low B+. We must find out the reason for the B+ being so low. As a field coil speaker, my heart is pounding because of the last radio I worked on. I got into a schmozzle with a field coil issue. Speaker works. I've proven that. Why no radio sound yet? Good question. I think I tried feeding a signal into the volume control. Nothing came out, so we know something between the volume control, which is the start of the audio, kind of the start of the audio in a radio like this, and the output tube, something in there is not working right. So what we could do, we can run the radio, try to tune in a signal, and listen to it as it progresses through the radio. So that's a good idea. Why don't we find out what is reaching the detector tube? So we'd want to hear the IF at its output point. And where would that be? Let's go look for it here. Where would that be? Just looking at the back here might not be a good start. A better place to start is looking at the schematic. So we have the IF here, and we have an IF here, and we have the output tube down here. So the signal certainly going this way through the radio. So this will be the output IF transformer going into the detector. So a good guess is this heavily insulated wire here. Actually, it's not heavily insulated, it just has a large sleeve on it. There's a red wire coming right from the power supply capacitor here, going right here, and then there's a wire coming out. Oh, there's also a capacitor going over here. I don't know what's going on offhand, but this is the area where we're interested, I'm pretty sure. Let's see if we can pick off some signal from there. What I would use to listen to it is this guy here. This is also a radio receiver. It's a different sort. It's not a super heterodyne. It's a tuned radio frequency receiver. And this thing will receive the broadcast band like any radio. I can hook up an antenna. I can tune around and listen if I wanted to. That's not really what it's intended for. It'll also tune through the IF frequencies. Here's the IF, a range of IF frequencies all the way from 170 kilocycles all the way over to about 500 kilocycles. So 455 is going to be just about at the top here, really, right? Just about at the top. So I can set this to 455, and then the listening is done with this. So we put one ground on, and this large guy here, there's a vacuum tube inside here, and the grid is coming out onto this probe, and this green tape is just trying to hold the end cap on. It's kind of ugly. So with the tube right here, that means an already strengthened and amplified signal is traveling back into here, not likely to pick up too much noise, which I think is a whole. It makes it, you make it more sensitive that way, I guess. So I think I'm going to take a little break here, and then we're going to do this. And oh yeah, no, we got to look at the schematic and figure out exactly where we're going with this. Right. Okay. Let's look at the schematic here. Okay. Here we are. Whoops. We are looking for right in this area here. So here are the two diode detectors here. So we could go, see, I've got the two diodes are just connected together in this arrangement. So here or down here might be a little bit of a problem. This capacitor is draining everything out here, so it might be weak, but we get a pretty good strong signal up here. Now what pins are this on the 12SQ7? I don't have these things memorized by any means. I have nothing memorized. That's the reality. I've been a bad actor all my life when it comes to memory. Okay, so we'll look for the one of the two diodes. One of the two diodes, my 12SQ12. It's probably going to say look at a 6, SQ7. Let's see what it says. 12SQ7. There we are. The two diodes are pins 4 and 5. So 4 and 5 on that tube is what we would want to listen to. So the tube in question has got to be this one here, the detector tube, and 4 and 5. Okay, so I'm looking for the key of the tube there. The one spot I can't see is where it must be. It's just exactly. Can't see it. How come? I can't see it here. There it is. So hard to tell. The pins are numbered. 4, 3, 4, 5. Here, look, these two are tied together. And look, they're going right here. This is where we want to test the signal. Okay, it's in the right spot we're going to start. Okay, know what I'm doing now? At least I believe I know what I'm doing. So we're going to put this onto the chassis. Ooh. How come so overexposed? What happened to my camera? See if I can just reset that. Okay, that's a little better. So practicing, and wire's not long enough. There we are, no problem. Okay, first we can turn this guy on here. No, you know what? First it's coffee time. Yeah, before I do this. Go drink some coffee. Okay, let's start up the signal tracer here. Now my little black cat, who has not appeared in many videos for a while, she's been pretty busy because the last 6 days she's caught 5 mice. 4 of them in our garage in the evening, and 1 in our house. I was really stunned. A mouse in our house? 5 of them in about 6 or 7 days. That's a mouse a day. Wow. Carnage. Every morning I get up. Carnage. Okay, so this is on now. This has a bit of a hum to it. Actually, it's feeding back there. So I'm going to set this to RF because it can also amplify audio signals too. It's quite a nice device. We're going to set it around 455, which is around here. I'm going to set the band on band A. Okay, so that's this band. So this is now going to receive any 455 signal or so. Now, is the radio running at 455? Well, who knows? But we can tune around a little bit and try to find it. So I'm going to be doing, there's nothing on. So I'm just practicing again. Wow. I'm going to do that, maybe with the volume down a little bit. And hopefully what we're going to hear is the sound of a radio. It's going to sound just like a radio, and maybe tuned in, maybe not at the start. Okay, the switch is on, the volume is down, power is on. So the pilot lights come on a little bit. 100 volts, 102 volts. Yeah, right, we're not going to hear anything out of the speaker because that's the whole problem with this radio. This volume control sounds terrible. It feels terrible. It's all scratchy in there. Hope it's not a worn out volume control. Okay. Well, we could listen right at the volume control, but we're set up to listen back here. So I'm going to go back. We're at 96 volts. Let's just go a wee bit higher. Up above 100 at least. Pretty sure at 100 a radio like this is going to work. Okay. Hand on the volume control of the this guy. Okay. What do we hear? Oh, just getting close. You can already hear it. So holding it close and tuning. Didn't I hear something there? Oh, yeah, I heard it. Okay, so the tuning capacitor appears to have bad connections. Interesting. Just holding this close, this is enough of an antenna here to just pick signals right up. So this guy appears to be, surprisingly so, hit and miss. That's surprising because it's underneath the chassis here. So I'm just looking for what you might call grounding springs. I don't see any. So the trick of these guys is the center shaft here is grounded. I mean, it's running right into the frame here. The frame is grounded, and if that grounding is a little shaky or wonky because this is a moving piece, then you can get the radio jumping around or making funny sounds. So I think what I'm going to do, because you kind of need to hear this, I'm going to put a clip lead on here and clip it onto the output here. Now, having long wires hanging out of a radio like this is not the best. Okay, let me turn the volume down on the tracer. We'll go on here. Is there any... No, there's not much voltage here. There we are. You can certainly hear that. Just overloading the front end of my guy here. So this thing has a lot of adjustments for adjusting that, for limiting the signal coming in, and then you have a volume control for what's going to the speaker. So these control what's coming in, and I can kind of look at this magic eye, which you can't see from where you are. It's coming and going. Yeah, it's jumping around a bit, but that's okay. Oh, see that? Very unusual. Look what I've done to the pointer here. Oh, I forgot about that. Oh. Ooh, what happened there? I just banged things a little bit. That's better. Wow. I said somebody else probably bent this. You know what I did? I just straightened it out. I've removed most of the bend here. So that ticking you just heard, that's not the radio, that's some external interference that I experience all the time here. So I'm going to spray a little bit of cleaner just in these areas where the center shaft contacts the frame. And now usually there's some kind of a springy fitting in here to increase the contact, but I don't see one. It's got ball bearings at this end, and it looks like ball bearings at both ends, which is a little bit unusual. Now, I can never tell there's actually fluid coming out of this. I just hear and see gas. Oh, there's a little bit of fluid. Now it's dripping out. Sounds terribly scratchy. Now another thing that can make it scratchy is the plates are shorting. But that's very unlikely. This capacitor's been under the chassis, totally protected. Something else is going on. And it has a large copper braid grounding connector here. That can't be a problem. So you think this frame has to be grounded to the chassis by that beautifully. So it's got to be this. Must be because they're relying on the ball bearings. You know what? There is a spring fitting in here. It's just really hard to see. Yeah, I can feel it there. Let's hit that. Now I often do this with WD-40, not with this is expensive stuff here. I don't seem to be getting anywhere here with this. push the button here. Yeah, just gas. It's receiving well. But you can see what will happen if this capacitor's in this position and I'm trying to troubleshoot this radio as opposed to that. Wow, how am I going to know what's going on here? I gotta solve this. I'm so surprised. Is it getting better? Am I wrong about the braid? How can I be wrong about the braid? No. How can you be wrong? Ooh. No, so yeah, I probably just flexed this. It has to be the contact between the rotating shaft and this. You see the outside fin here, it looks like it's been bent outward slightly. And that could have been done in the factory on purpose as part of the alignment of the radio. You can also see it's jumping around tuning wise. All indications of trouble here. Okay, so this deoxit didn't do the trick. What about my tried and true WD-40? Now there's lots of talk about don't use WD-40 here, there, and everywhere. I have great success with it. A little round of applause there from the any one of these makes good contact, and that's the end of the problem. I almost fell over there. My foot caught on the wire for the camera. Let's take a closer look at what's going on with these ball bearings here. Lots of strange interference sounds today. Okay, trying not to forget that the radio's on. This little camera I'm holding, that you're looking through, is actually grounded on the outside. There's some metal parts that don't look metal. You can ground yourself with this. Okay, so looking at the ball bearings here. See, it looks like it's full of grease. Does it really? Does it look like that? I think it's getting better and better, actually. I guess, you know, in rolling ball bearings, if they're a little dirty or something, it might take an awful lot to kind of... Now the ball bearings at the back, are they even moving? Come on, camera. Oh, I just... Okay, hold it there. They aren't moving. Are they? Oh, they're moving a little bit. The ones up front here. Yeah. So you can see the black. Wait a minute, is that a ball bearing? Yeah, that's a ball bearing, isn't it? I bet you those aren't rolling. Pretty hard to tell. They're set in little things, and then there's a black grease all around them. I bet you they're not rolling. So if we stick some more WD-40 on there, it might penetrate and loosen up that oil and get those things turning. That's my guess. It's definitely better. Much better. I'm not picking anything up anymore though. So I think the local oscillator, this part is the local oscillator. I think it's really having trouble. How come this grounding spring isn't working here? Now, if I flex it, maybe we can determine that it's not working right. It's definitely springy. Let me show you that. It's very hard to see, so that's as much as my camera, this little camera's a little awkward. So you can see the yeah. So this piece of metal, and then is it just sitting on here? It's probably attached somehow to this. Doesn't look like it. Maybe it's just sitting on here, which wouldn't be the best. Yeah, this metal here, clearly it has got a patina on it, and the patina may or may not be conductive. And then this thing is just sitting on top. And you can imagine that underneath there's patina, and this may not be making very good contact. The plate itself looks really shiny, so I think it's some kind of, it's got to be a spring metal of some sort. These ball bearings. Let me just get a stick here. And it could be the case that, you know, if this is making a good ground connection here, but this one over here is hit and miss, or this one's hit and miss back here, that might be enough, even with this doing a good job. In a large capacitor, there'll be quite a number of places where they're trying to ground it. So I'm checking to see if this black stuff is it? It's more like like it's solid. Well, I think the name of the game is to hit this with more solvent. Maybe, you know, throw some alcohol in there, and really let it spend some time. It's definitely improving, though, isn't it? Look at that. Actually, that interference is helpful now. Again, the pace at which that thing is going has nothing to do with the radio. That clicking, buzzing. Hey, it's working pretty good now. Okay, well, we got past. That's good. That's good. This was a very serious problem I didn't really realize was there. And it is unexpected because the capacitor is hidden under the chassis. I figure, wow, what's going to be wrong with that? Yeah, this has come along after a lot of working of it. But I'm going to throw some alcohol on that. How about a little alcohol? How about I find the alcohol? drip technique here. Drip some in there. I named this the drip technique. It's my own name, but you can use it too. I like alcohol. I like doing this with, say, rubbing alcohol because it can't. I don't think it's dangerous. I suppose it could maybe catch fire, but that's not going to happen. But I mean, it's not dangerous. You get it on your fingers, or. Although I'll tell you something, alcohol that we drink. I drink the occasional beer. I think of that alcohol as what it actually is. It's a solvent. And drinking alcohol is akin to sniffing glue. Now you might say, what? Yes. They are cousins. Both are solvents getting in your bloodstream, messing up your brain. It just strikes me that solvents, eh? Drink that beer, sniff that glue. So I don't drink very much. I'm Canadian here. I have another pastime. Let's see how this goes. I'm going to turn up the So now it's connected almost all the time, I think. Is that connected? We didn't hear a station. That's not connected. Where'd all the stations go? Hey man. We really fixed it good. Huh. What happened? You can kind of hear him now and then. Oh. There's got to be something more to this.
Maybe you can sell it. Sure. If you're sick, stay home and work. It's a great option. Just stay home and do your thing. But no one really needs a hybrid model. Those employees got it enshrined in the last contract. With raises, more sick days,
This
and
band
we
here.
lose productivity. 10 to 20%.
So if we look and see these two adjustable capacitors here, they have it's a common metal band going right across. And the band is bent around this piece, where no doubt it's supposed to ground. Do you think this is the problem? Let me turn it up here.
3 hours of sitting around and waiting was able to get my passport renewed. Even just renewed. I've been trying to get it renewed for so long. Sometimes I'd go to a place and try to book an appointment, and when we come up, just no appointments available. And not even like
You have to walk over to Victoria.
finish work here and just hope to God.
Don't really know what I'm doing there.
Right over there. We got over there. 12:15
It's
out
a hair
there.
trigger.
Guy said, would you do it?
Yeah, hair trigger's right.
Yesterday I knew it, but like,
Jeepers.
You gotta go in. 30 of them, okay, 4 people.
that's the point.
Yeah.
Like,
I mean,
for a short while, there is... That was happy. That was on that third of those windows, and there's like rotating bricks, whatever. But when you're sitting there and that radio room is full, you're not seeing anything going down. That's infuriating.
or even worse when you think your window's coming up, and then you see one clerk come over talking to the other clerk, and you know they're talking about, I'll take my grade first, and then don't even think about it.
I do want to give one thing though, so you have to say the people who like, after all so long, right, they finally get to the counter, they were nice to me.
What did I just see here? What did I just notice? Okay, we're going to flip cameras. I'm going to freeze the focus on this because I think I just hold on, I'm losing my mind here. I think I just saw what I've been chasing after here. This is the okay, so I'm talking and making a mistake of what I'm doing. So I'm just trying to bring up the dialog box for the camera here and freeze the autofocus and move it way up. Okay, let's go see. Let's go see what I saw here. Okay, I got the set on. I gotta be careful of it. If I look up at the TV screen, I'm not looking at what I'm doing anymore here. See that? Do you see the short circuit there? Okay, I'm going to turn the set off because I'm just sticking this camera right in and not looking at what I'm doing. I'm going to move the capacitor a bit. There it is. That's the problem. How many of these radios ran into this problem? So it's clear what I got to do. I just got to move that wire away from there and we're done. I think that's what I've actually been chasing all this time. Okay, just sets off and that, so I don't care what this is. Who knows what that could have been? Could have been grounding out some high voltage thing or something. But, oh, I need a finer blade. This is a job for the Swedish fish knife. Do you have a Swedish fish knife? You go down to your Swedish fish knife store. I think there's a department in IKEA, and you can get your fish knife. Wow, this lug is just as solid as can be here. I'm having trouble bending it. Just need enough clearance to make sure it doesn't happen again. Crack. Okay, let's take a look at that. Yeah, no shop is complete without Scandinavian or Nordic fish knives. Okay, we got clearance. The clearance has been found, has been set up. In the meantime, we've lubricated and cleaned everything. Okay, let's give it another go. Okay, power on, volume down. And we're still hooked up to the signal generator. We're listening to the speaker, the signal generator, speaker on the tracer, signal tracer. We're not listening to what's coming out of the radio yet. Come on, radio. Play me some sound. What happened? Oh, I turned it down. Yeah, just turned it down. Watch this now. Hey, fixed. Hey, not fixed yet. Come on. You're kidding me. Oh, yeah, come on. So there must be something holding the capacitor in place, and it's a little shaky. Let's try that. Let's go after some mounting screws, because again, it may not be that this is go no go. What could be happening is the local oscillator, for instance, tuning is being thrown all over the place, and with this that could be what's happening. So I want to flip it over and look for some screws to tighten. Yeah, tighten the screws on the thing. Okay, and we're power's off. Fish knife to the side. I wonder, would that knife cut things more than fish? Or is it just fish? Now, screws that are holding the capacitors. Let's see, 3 of them here. on grommets, but we know there's a big ground band, so the capacitor frame is grounded. Okay, that doesn't matter, does it? Tighten these guys up. They're pretty tight. They weren't particularly loose. But the grommets, of course, have given out and squeezed down. Let's see if that's... oh, not that. This. There's still some play in it. No, not that. This. No play. No play. Okay, what do we got now for a radio? Let's flip it over. This way. Was it like this? Yes. And we gotta lift it up here. I'm gonna ruin that pointer sooner or later. This guy. Ooh, careful there. There we go. Okay, we're back in business again. I have the tracer on. And right, okay, we're ready. Here we go. Everything's okay. That's fine. This is fine. Okay. Here it comes. It's still doing it. Much better though.
If it wasn't, it'd be what?
It's gone from mostly off to mostly on.
$1 million and do whatever. Try.
Terrible. Well, no more of this.
Summarizing every
Trying to imagine, could there be something else now? Could there be a plate contact in here? When it goes completely silent, that suggests this thing is shorted out. Let's take a look at the plates here. Okay, this is a little tricky to do. Let me bring in my... See, on my videos you get to see everything. Even if you don't want to see it. Okay, so we're trying to line this camera up to look right down the plates, and then we're going to move the radio around probably. And try to look down every plate and see if we can spot anything. It looks... I'm going to turn down the volume here and we will focus this guy here. Okay. So I'm literally looking at every plate individually, one at a time. See that one that's bent way out on the right side? Let me point to it. This one here. Is it touching down at the bottom there? Way down here? Can't see it in the camera there. Doesn't look like it. My camera's slowly sinking. It's very close, isn't it? Almost like when they bent the plate out, this part went in. It's very, very close. So I'm going to bend that little tail out there. Actually, if you get it to the, if I get the radio to a sensitive spot, there, and then touch this plate. See, that's not the problem. It would act up. Somewhere there. Okay. This seems pretty solid here. This is probably spot welded. I think you can see a little a little thing here. It's not sensitive. Now the radio's working right now, so it really doesn't like that, does it? Sure seems like it's the local oscillator. Poking around here. Reaching at straws here, but so even when it comes on, it doesn't necessarily come on at the same frequency. Holy smokes. Dead spot. You know, how could it be that I'm losing ground contact here twice, and here all at the same time? It's just okay. So what I'm going to do, I'm going to go on the assumption that this is as good as it's going to get right now, as good as it's going to get right now, and it would be the radio's reliable enough. I can continue doing other things, and I know enough to check the tuning in case it's gone quiet. I can always keep my tracer on back here to know that the radio's working or not. let's listen to this radio now. So we're going to turn down the tracer so you can't hear it. Turn up this so you can't hear it. There's nothing there. It's just nothing there. And we're going to go looking for it now. Okay, no, I've kind of done this. This was dumb. Don't go do that. Okay. Now we're going to use the signal tracer to look for audio at the volume control. We'll start tracing the signal. So I'm flipping my tracer here. Okay. Audio should be coming into the volume control, the input to the volume control through this capacitor into the top of the volume control. So we should hear it full tilt here.
Or you call a lawyer.
There it is.
Rights at disabilityrights.ca. Fight find out how. disabilityrights.ca.
Output from the volume control. Okay. Input here. Output, actually. Output from the almost the same place I've been listening to. Like they're taking it from the others. Okay, fine. So we know the volume control now. Volume control output is working. Back here. Wait a minute, that doesn't make sense. What? This doesn't make sense. What am I looking at here? It looks like the input signal is coming to the center terminal and the output is going this way. No, that's not right. I got the other way around. So, am I not tracing this wire right? So we know the output is outputting. Time for what?
What's it looking like? Jim, we can expect more thunderstorms as the evening approaches, and then overnight. Hold on. Oh, yeah. Can I get Jim number 6 over the side of Curly?
I don't think that was a real weather report. So we have audio leaving the volume control, heading towards the triode in the detector tube. The triode grid of the detector tube is 12SQ7. Pin number 2 should have the signal on it. Pin number 2. Pin number 2 of the detector tube. And here we go again. I can't see the. I can't see it. I need my very bright flashlight. Okay, I'm going to stop for a minute and get a very bright flashlight here. Okay, let's try this blasting light here. There it is. I do see it. So that'd be, and I've forgotten the pin number I'm after now. And I closed the book. Oh boy, 12SQ7. You probably remember the number, but I don't. 12. And if I did, I doubt myself anyway. SQ7. 3, wasn't it 3? It was 2. 2, 2, 2, 2, 2, 2, 2, 2. Okay, so we would locate pin 2. 1, 2. Looks like some bad soldering on pin 2 there. Scare myself with the light. Okay, so we're going to listen to pin 2 audio. Pin 2. So that's the grid of that tube. So the signal is going all the way through the radio right to the grid of that tube. We've got to listen to the plate now and see what's coming out of it. Or we could go grid of the output tube. Oh, good, this thing's working this far and we're not hearing it coming out the speaker. So 12SQ7 again, plate is number 6. So on the plate we should be able to hear pin number 6. It's 1, 2, 3, 4, 5. Pin number 6. Oh, wouldn't you know it? Pin number 6 has the new capacitor attached to it. That makes a lot of sense. That's the capacitor taking the signal away from the tube and going into the output tube. So what's coming out of this tube? Here we go. It's blasting away. Now what's on the other side of this capacitor? So we're right to the output tube. Remember I measured the output tube as being weak? That's all it's been all this time. Just a weak output tube. Okay, what is it? Right on the grid of the output tube. You darn output tube, you must be the problem here. Okay, so we're going to retest that tube, and certainly I'm going to replace it, I'm pretty sure. Okay. Okay, I think we're about ready to test this tube. Let me just double check. 35L6, 35 filament voltage, highest signal level, number 8, 14H on the bias, 07345, 07345, and 0610, 43 D. Good. So I'm pretty sure last time I tested this tube it came out low, and I thought to myself, well, this can't be responsible for a totally silent radio. That was my thinking on this. That may have been bad thinking. Okay, let's do the shorts test. Nothing showing up. Okay, and we're going to test it now. According to this tester, this should come up to 990, 35L6, 990, so 1,000. Up to here, here we go. Holy smokes. Well, I remember this is testing badly. That's not bad at all. That's very good. So I probably don't remember it right. Let's just double check everything here. 35L6, 814, 07345, 07345. I think if these buttons are wrong, then I think the test would fail. Terribly, 43. Everything is correct? $990. Yeah, 1,000. So, well, this isn't the reason why the radio's quiet. So the signal is reaching the grid of this tube, but not coming out. How could it not be coming out? No B plus on the tube. No B plus on the tube. Open output transformer. Ooh, don't like that conclusion. Okay, I'm gonna put this guy back in. Okay. So we'll look at the output now. If the output transformer is open circuit, there'd be no B plus on the plate. The plate of the output tube. 35L6. 35L6, and the plate is pin 3. So I thought I checked for this voltage earlier, maybe I didn't, because that's why I haven't returned to it until now. Now we have to double check it. So to do that, I'm going to turn this guy on, put him up like that. We have to turn on the radio. I'm going to take this off now. So so you won't be hearing anything. And this ground, wrong thing. I'm grabbing the wrong thing. Now I'm grabbing the right thing. Okay, I'm going to put the B minus wire back on. Where did I have that before? Uh-oh. It would look to be I could do it right here. That's the chassis I'd be connecting it to. Let's just do that. We'll see what happens. Well, then I don't need this clip lead. Instead of going on B minus, go on there. I think the reading may be somewhat falsified by this method. Okay, we're plugged in. Antenna is still connected. Not that it matters. We're on. And the pin was, just double checking, 3 on the output tube. So that's here. I'm going to put a little more, put the light back on in my shop. Pin 3, 1, 2, 3. It's on this green wire, which is one of the wires heading up to the, I've done this. I did this, didn't I? So this is plate voltage with 102 volts on the radio. Right here. Oh, wait a minute. Looking at this meter, you can't quite see the meter. You missed the excitement of this here. Okay, we're on positive 150 volts. That ought to do it. 3 on the green wire. Right here. And the B plus is, yeah, I've done this already. B plus is really not there. This is really the problem. I sort of arrived at the same problem in a couple different directions. So the other side of the field coil is this wire here, I think. See, that's low too, because that's a 50 volt scale. That's 26 volts. Okay, so we just work our way back a little further. Go look at the filter capacitors again. Everything's low. Why is everything low? That one's not. That one's not low. So this is right off the rectifier here. So now we're looking at 75 volts. Still not really where it should be, but 75 volts. That's the input to the field coil, and the output. No, it isn't. I got these mixed up. I've got these mixed up. Before I said that was a field coil. It's not. It's just a plate. And it's going up to the output transformer. That's what's going on here, these two wires. I'm just misspeaking. So, would you expect to find a great big voltage on there? I would think so. So going back here in the rectifier, we got 75 volts there. Would be happier if it was more like 120. And then it comes over to this capacitor. Is this capacitor just dragging everything down? No hum, but then again no hum because the supply voltage to the output tube is so low the speaker's not being driven. That's the thinking. Why we know the radio signal is sitting right on that grid and we can't hear a thing coming out of the speaker. So with the low B plus, the tube is probably sitting in cutoff. That's probably what's happened. That's my guess. Which is why it's so silent. So maybe the filter capacitor is responsible for all this. and dealing with that is going to correct it. Now, if the capacitor is drawing down the power supply, it's got to be getting warm. And it's a big thing. It might take time to actually get significantly warm. So I'm going to turn this off. Flip it over. It's the capacitor inside of a cardboard shell. So, how am I ever going to tell that it's getting warm? This is warmer. Hard to tell. So, yeah, I think I have to replace the filter capacitor. I think that's what we'll look at tomorrow. We'll assume, it's a good assumption the filter capacitor is a problem of some sort anyway. Even if somehow I got past whatever's happening now, I might have a hummy radio anyway. Of course, we didn't hear the hum through the signal generator. We didn't hear the hum through the signal generator. There's no hum. Yeah, we'll worry about it tomorrow. Thanks a lot for watching, and just carry on a little further tomorrow. Keep plugging away. See ya.